continue with another part of the review, problem number 6 through number 10. And actually the rest of the review is like, it's not like the first part. In the first part you have, you don't know if the variables have positive or negatives, and then that's why we have to insert absolute values. But the rest of the review, they tell us that these are non-negative variables, so we're going to use, we don't need the bars in the rest of the review. So problem number 6 is just simplify the radical expression. Number 6, we have square root of t to the 5th power. Okay, so since this 5 is not divisible by 4, we need to break down t to the 5th power in 2 powers, so one of them has perfect square root. So that will be t to the 4th and t. Okay, so I'm going to write t to the 5th as t to the 4 times t. We continue, 4 divided by 2 is 2, so this is t squared, and t stays inside of the radical. And that's the answer for problem number 6. Problem number 7, we have 4 root of x, no sorry, number 7 is square root of 45 x squared y. Okay, so in this case, if we look for square root of 45, 45 is not in this column, but so then that means we have to break down 45 in 2 numbers, so one of them has perfect square root. So it seems like it's 9 times 5. So I'm going to write 45 as a 9 times 5. X squared is perfect. That's going to be part of the one is going out to the radical. So that's going to be 9 times x squared. I'm going to leave x squared next to it. Times 5 to complete the 45 and the y. There's nothing we can do with that. So the red part is going to be inside of the radical. And 9x squared is a perfect one, so that's go out. That's going to be square root of 9 is 3. Square root of x squared is x. It's positive x because it's we don't need absolute values here. And square root of 5y. And that's the answer of the problem. Continue with number 8. Number 8 is square root of 320 k to the 7th q to the 8th. Okay, so we're going to break down 320a in 2 numbers, because if you look for, if you use a calculator for that, 320 is not in our table, because we just have it until 100. So but 320, let's find in square root of 320. Square root of 320, we observe this is 17.88, so it's not perfect. So we need to break it down into numbers. So what you start doing is dividing 320 divided by every single number here in the square root, and you're going to find out that you're going to get a perfect answer when you divide it by 64. So you have practice. We did this in class. So when you divide this by 64, you obtain 5. So you have 64 times 5. So I'm going to, k to the 7th also can be k to the 6th times k. And q to the 8th is perfect, so that one stays there. Okay, so I'm going to write 320 as the multiplication of 64. K to the 7th is going to be k to the 6th power. Q to the 8th is perfect, so it stays next to that part because this part is perfect. Now times the rest of it, which is 5k. So get the square root of that part, which is 8. Okay, 6 divided by 2 is 3. 8 divided by 2 is 4. Q to the 4th and square root of 5k. That's the answer. Problem number 9, we have cube root of, number 9, we have cube root of 343 x to the 4th y to the 5th. Okay, so if you observe 343, look for 343 in the cube root column. 343 is right here. Cube root 343 is 7. So 343 is a perfect cube root that I don't have to break it down. X to the 4th, I do have to break it down because it's 4 over 3 doesn't go evenly. So it's going to be x to the 3rd power times x. Y to the 5th power can be written as a y cubed times y squared. So I'm going to rewrite this as 343, cube root of 343, x to the 3rd power, y to the 3rd power times, I'm writing the rest of the factors, which is x times y squared. The answer then is, get cube root of 343 is 7. So we have 7 x to the 1st power, y to the 1st power, cube root of xy squared. Remember, once the exponents inside are less than the index, then you are done. That was number 9. Let's do number 10. Let me erase these two parts from here to do number 10. Number 10 is 6 root of x to the 6th power, y to the 11th, and z to the 5th. So 6 over 6. We don't have any coefficient here, so we don't have to worry about that. 6 over 6 is 1. 11 over 6 doesn't go evenly, so I'm going to break down y as a y to the 6 times y to the 5th power. This one is already, 5 is already less than 6, so there's nothing I can do with z. So just rewriting this, you're going to have 6 root of x to the 6, y to the 6 times y to the 5th power and z to the 5th power. So the answer of this is going to be x, y times cube root of 6 root of y to the 6th, y to the 5th, z to the 5th. And that's the answer for number 10.